So let's get started. So we're going to be doing some object pooling today. So object pooling is great for when you have a lot of different objects coming into and leaving your scene. And a great example of those is bullets. So I set up a little scene here, just a little blue dude, and we can play, and you can see he'll shoot bullets at the mouse. So right now he's not shooting too many bullets. You'll notice my bullets are disappearing. I actually have a boundary that once they get out of that boundary, they disappear. So at most we have, 5, maybe 6 bullets at a time. But you can see that in the hierarchy, they're being instantiated and destroyed when they come into and leave the scene. It's not bad when there's only a couple of them, but let's say our player picks up a machine gun or something that shoots a lot of bullets or 3 bullets at a time, whatever. So if we crank this up to, let's say, 1,000, it's not going to quite get up to 1,000 just because of, cycle rates. But now you can see the hierarchy is just completely full of all these clones. And if I stop shooting, you'll notice all those clones are going to start getting destroyed and removed from the hierarchy. Um, this is okay when it's just the player, the one guy shooting bullets. This can get kind of crazy if you have a bunch of enemies spawning, a bunch of bullets spawning, things coming into the scene, things coming out, because when you destroy things, they go onto a sort of heap where Unity will go in every once in a while and garbage collect, and that can cause performance to drop, and so you'll get noticeable lag. Um, so what we want to do is we want to create a pool of objects that are just in the scene constantly, and we reuse them as they either hit the edge or hit an object or hit whatever. We're not using them anymore. So I'm actually going to go ahead and create a new C# script, and I'm going to call it object pool. Open this up in MonoDevelop. All right, so now in our object pool, we need a couple of things. We want to be able to access the object pool from anywhere, so we don't have to keep handing references off all over the place. So we're going to use a singleton. So to create a singleton, I'm going to create a public static, and then this type, object pool, and call it instance. And in not start, but awake, and we do this in case we disable or enable the object pooler, because start will only be called once when an object is first loaded into a scene and enabled, whereas awake will be called whenever the object goes from disabled to enabled, and we can call it multiple times without having to destroy and reinstantiate the object. I'm just going to say instance equals this. So if we accidentally put in multiples of these, they're going to start overriding each other, but for now, it's just going to be one, so we won't have to worry about it. All right. And the way we're going to control all of our objects or keep track of them all is using a list. So Unity doesn't have lists included by default, so we have to add a using. So I'm going to do using system.collections.generic. That's just where the oh, I already have it in there. It's where the list object lives. So now we can say public list. Oh, sorry. See if I can crank it up for you. Is that better? Hopefully. I think it's actually turned all the way up. All right. I'm going to say public list and give it a type of game object. and name it, where did I go? Pooled objects. So this is the variable that's going to hold all of our lists, or all of our objects. Sorry. We also need to know what object we want to pool. So public game object. Let's call this object to pool. Object to pool. And then we need to know how many. So public int num count to pool. Sounds like a weird vampire. So this will let us instantiate X number of objects when we start up and hold on to references to them. So in my awake, whenever this first runs, I'm going to say pooled objects equals new, because we have to instantiate our list of type game object. And so whenever our pool awakes, it'll spin up a new set or a new list to hold in all our objects. And we're going to loop with a for loop int I equals 0, I is less than count, and then I plus plus. All right, and we just want to get a game object and hold on to a reference of it that we are going to instantiate. And we're going to say just the object to pool. So this will give it the default, whatever is in our prefabs, position and rotation. And that should be a semicolon. And we want to set it to false, or set its activity to false, so that it doesn't come into our scene active. Set active. So then no scripts will run on it. The renderer won't happen. It'll just be an invisible thing inside of our scene. And we want to add it to our pooled objects. Add obj. So now we can jump back into Unity, and I'm actually going to use an empty to hold the pooler. Let's say, let's call this a game controller. This might have other scripts on it that you only need one instance of that don't have like a physical representation in the scene. And I'm going to drop our object pool onto that object controller. So now you can see our pooled objects, it's empty, and I already created a prefab for our bullets. I'm going to drop a bullet in there. And let's say we want 20 to start. So if I hit play, you'll see the game controller and you'll see 20 instances of this bullet, and they're all disabled. They all exist within the scene, but they're not taking up any CPU resources. They're just kind of hanging out. So what we can do now is get access to our pool and request an object from the pool wherever we want to instantiate a bullet, whether it be this player, an enemy, what have you. So we're going to go back into the pool, and we're going to add a public method. And it's going to return a game object of whatever our pool object is. Get pooled object. Doesn't need any parameters. And so we need to return something. So if we don't find any objects to return in our pool, we're just going to return null for now. But we want to iterate over our list of pooled objects and find one that isn't active yet and return that pooled object. So we're going to do a for loop, say int I equals 0, because we want to start at the beginning. 0. I is less than the length of our pooled objects. What does it count? Count. And increment by 1. And we can just say if our object, pooled objects, get the array index, dot active in hierarchy. So active in hierarchy is if the object itself is active. There is a regular just active. Um, this only references I think it's the parent, and active in hierarchy is all the children too. So if we put all our objects in a container, like an empty game object, and that empty game object is active and all the children are not active, active will return true because its parent is active. The opposite's true. If the parent is deactivated but the child is active, it'll still return true even though it's not active in the scene. So we want to use active in hierarchy to get our specific object. And then we just return pooled objects I. So this will return a reference to whatever object is not active. And we have to remember that it's not active yet. So I'm going to go into my shoot. And this is where I instantiate my bullets. Right now, I have this fire bullet. And what it does is, we don't need that raycast in there. What it does is it just gets the screen point of wherever the mouse is, normalizes it to be the same height as our object. Hey Blake, how's it going? And then we figure out the angle between where whatever it is shooting to where we want to shoot to. So this will just give us a vector from the player towards the mouse on the same plane as the player. Sweet. I also threw a little catch in here. If you put the mouse exactly over wherever you're shooting and the magnitude of that angle is just really super tiny, we just default it to forward just to kind of avoid some problems in the future. And then this is a normal way to do it, or if you're not instantiating a lot of objects, I just say instantiate the prefab, give it the position, offset it from whatever we're shooting from a little bit, and whatever the default rotation of the bullet is, or the prefab. And then I just say, look at wherever I want to shoot, wherever I am, plus whatever the angle is. So that'll give me a vector from the player to the mouse. So we're doing object pooling. Right now we've got it set up that we can spawn tons and tons of bullets. Let me crank this up, which is okay in this case, but if we get a lot of bullets spawning and being destroyed all at the same time, we can run into lag issues. So we're using object pooling to avoid the creation and destruction of objects, and it makes it a lot more performant. So it's not really a thing we're making, it's a tool we can use to make our games better. But right now, so we've got our object pool already created and instantiating objects. Now we just need to request an object from that pool. So instead of instantiate, which we have in our object pool, which happens at the game creation, we can say object pool dot instance dot get pooled object. So what this is going to do is this is the static class. We're going to get the instance, whatever is instantiated, and then we can get an object from that. Cool. So now we have either a bullet that is not active or we have null. So if there are no more objects in the pool, we'll have null here. So we should probably check and see if we have a null. So if we say new bullet, I guess this is not really a new one, is not equal to null. Do we want to do not equals? We'll do not equals to null. So if we actually have a bullet that we can spawn and mess with, we want to do something with it. So I'm just going to move this guy up. So we have a bullet, but right now, or at this point, that bullet is wherever. It's somewhere in the scene. It could have been moved. It could start at the origin. Whatever. We want to make sure it's where our player is. So we say new bullet transform dot position equals our transform dot position, and I'm going to add the fire angle dot normalized. So normalized just turns, if this angle is teeny tiny, it just makes it 1. So we're always shooting from a set distance away from wherever our position is. And then, so we set the position. Now we need to set the rotation, which the look at takes care of for us. It's important to set the position before the look at. If we have just a static, rotation equals whatever, um, we could do them either way, but because this look at takes into account what the position is and where we want it to look at, we need to do it second. So we put the bullet in position, we have it look at our mouse essentially, and then we need to essentially turn it on. So I'm going to say new bullet, set active, true. So then we put our bullet where we want it, we turn it to face the right direction, and we kind of just let it go. That's like the firing of it. So if I start up the game, I guess it was compiling. You'll see all my bullets are already in the scene. If I start clicking, I've got it turned on 1 second. You can see, 4 or 5 of these are becoming active, and then, well, they're still disappearing because they're hitting our edge and blowing up. But I'm not instantiating a new object. I'm getting one that's already instantiated, saving my CPU cycles from having to, allocate memory and put it in the scene. So let's go into our destroy script. So kill on exit. So right now I've got it, if the bullet exits our zone, it gets destroyed. And we don't want that because that means we have to spin up a new one. So let's do other.gameObject.setActive and just make it false. So whenever our bullets hit our edge, if it hits an enemy, a wall, whatever would stop the bullet, we just set it to false, its activity to false, so that it's no longer in the scene, but we physically in the scene, but we still have it in memory and we can reuse it. Let me jump back in here. I'm actually going to crank this guy up a little bit, fire a couple of bullets, and you can see they're active here. I don't know how well it's coming through on the screen, but they're on, and then once they hit the edge, they turn off. So you can see I've got a couple way out here. There's one there out on the edge, but then the rest are still at the center. You're going to select this first one, and if you watch this checkbox, this is what makes it active or deactivated. And so if I shoot it, it becomes active, it's in the scene, it's running around, it's hitting stuff, and once it does, it becomes deactive, and it goes back to our pool. So now we've completely mitigated having to instantiate and destroy a whole bunch of objects. So now you're thinking, I've only got 20 bullets in my scene. So right now the player is going to shoot 35-ish bullets per second. So if I click and I hold, I'm going to shoot all 20 bullets and I don't get any more until they hit the wall. Now I can start shooting again. So this can be a feature of your game. You only get so many bullets on the screen, in the scene, what have you at a time. I know older video games, like I think Asteroids does this. You only get 3 bullets at a time. Um, and you can implement that easily with this pooler just by going in and say, okay, I only want 3 bullets. If we play again, I can shoot 3 bullets. Let me turn up the shoot speed. Let's make it 3 bullets per second. I can shoot 3 bullets, and then I don't get any more until they hit a wall or hit something. Let's implement that really quick. I wanna have an object to shoot because It's not quite as much fun when things just, disappear. Let's scale this cube way up. Big old cube, box collider, and I don't think it needs a rigid body. So when you do collisions with Unity, one of the colliding objects has to have a rigid body on it. I know that a lot of newer developers come up against that. They say, oh, I've got two colliders and I'm moving them into each other and nothing's happening. It's because one of the objects needs a collider on it. So we've got our cube, and let's say, where's our scripts? So we can't use this kill on exit. So we can either modify this to be, on collision, destroy it, or we can create a whole new one. Let's create a new one. Say this is our enemy script. Kill on hit. Open this guy up in monodevelop. I'm going to say void on collision enter. I think it's collider. We can say if col.tag equals bullet. Instead of destroying the bullet, we just say set active false, and this will return that bullet back to the pool. And we will also do like, blow up, die, whatever the object we're shooting has, take damage. And then we just drop our kill on hit. Uh-oh. Has to be of type collision, not guided collider. So collision. So collisions don't have tags, but collisions do have game objects, and game objects have tags. Let's go back in, hit play, shoot a bullet. Boop. Oh, I guess it didn't collide. Flash, convex. Do we need to make this guy convex? No? Maybe we need to make the one on the bullet convex. Prefab, bullet, are not convex. I always get messed up with whether something should be convex or not. I don't know if you guys have had that problem before. Oh, why aren't you colliding? Is it too high up in the air? Passing right through it. You have a rigid body. I don't think kinematic matters in this sense. Kinematic is it's moved by something else. Mesh collider, rigid body. Maybe they both need rigid bodies. You're not going to use rigid body. Oh, I guess we don't need to be kinematic. That is weird. Oh, here, non-convex mesh collider with non-kinematic rigid body is no longer supported. All right. So let's make this guy convex. Oh yeah, see, all right. So now you can see I can shoot 3 times, and I only get 3 shots until one of those gets destroyed, and my cube is floating away. So if we use gravity, let's have a little fun with this guy. Use gravity. I'm going to make the mass of the bullets. Let's make it pretty big. This should send it flying. Boop. Oh, it moved a little bit. Let's see if we shoot it a lot. I'm going to get my 20 bullets. I'm going to have my player shoot 85 a second. Oh, we broke something. That's actually kind of cool. Is it because I made this non-kinematic? Or are they colliding with something? Oh, they were colliding with each other. So when I made these bullets non-kinematic, they would render in the physics system, and you can see when they spawn, they're very close to each other, so they're colliding with each other, and the physics system tried to move them away from each other, and because the script that moves them just just moves them straight forward. Whatever the forward vector of the bullet is that's the direction it goes, and because they were being affected by physics, they started doing the weird spinniness. So now, so you see, I can shoot 20 at a time, right? And it's pushing it further and further away. If I move the cube really close, I should be able to get just tons of bullets constantly. And if you look at the hierarchy, not all 20 are active at the same time. But if I fire them off into the distance, I can't shoot anymore until one becomes deactive. So this gives me a limiting factor. So now what if we want to do it the other way? What if we want just unlimited bullets, um, and we can keep firing, firing, firing? Well, the cool thing about lists is we can dynamically expand them. So like if we want to give the player, unlimited bullets, we can expand our pool as needed. Um, and so if we need like one or two bullets later on, that's okay. It's a lot better than adding, 30 or 40 at a second. So in our pool, let's let's be able to set it. Let's be able to say, do we want to allow this to expand or not? So I'm going to say public bool can expand. And let's let it be true by default. So now in here, if we find that we don't have an object, so the function will return here if we do find one, but if we don't find one, we return null. Instead of returning null, let's check if can expand, and if we can, then I'm going to create a new game object, stick it in the pool, and return it to whoever's requesting it. So game object, I can probably refactor this better, but I'm totally repeating myself. No, we don't need to cast. And now I can't type. Instantiate object pool. So now we've got a new one. We want to set its activity, set active to false, just like all the other ones, and return it. Oh, actually, we have to stick it in the pool first. Pooled objects.add object. Now we return the object. So because our pool is keeping track of it, we can give it to whoever's requesting it. If we can't expand, then it'll break out of this and return null. So we haven't really changed functionality, we've added functionality. Cool. Any questions out there so far? You guys are fairly quiet. Um, so let's jump back into Unity. I'm gonna go into my game controller after it compiles. And now we've got this can expand. So if I disable it, let's turn this guy back down to 3. We get the same functionality. We can shoot 3 bullets until they disappear, and we can't shoot anymore. Wait for them to disappear. 1, 1, 2, 3. 1, 2, 3. Cool. But now if we check can expand, I can shoot a whole bunch of them, and you can see my object pool just got a whole ton new objects. Hopefully that doesn't really happen in your game where you get a whole bunch at once, but our pool can expand. But now we have all these objects in our pool to use. They're not being garbage collected, which is another big source of lag. So even though we're expanding and instantiating a bunch of stuff, we still get the benefit of not garbage collecting. Turn this guy down a little bit. So there's probably a ton in there. So now I can shoot tons of objects. You can see it's still expanding, but there will be a point where it will kind of balance out. Yeah, and you can see every once in a while there will be a ripple of disabled objects that flip through the pool. There it goes. There's one. I don't know if you can see it on the stream, but it's a lot more performant. There's no garbage collection happening with reference to these bullets. Kind of cool. All right. And that's kind of all I had planned. I was just going to kind of play with this for a while, make a bunch of bullets, change some settings. If there aren't any questions out there, give you guys a second. And you can take this and put multiples out there. So if I want to pool, bullets, if I want to pool um, enemies, it's very easy to modify this to allow you to do that. You could even modify this to be a pool of pools. So you can add multiples to the same script, which gets a little more complex, and you do a lot more looping. Um, but otherwise, should be okay. Let's see if we can get this to work. Um, so we already have an instance. So we want to turn this from a singleton to not a singleton. Bet we can do it by tags. So let's say public, oops. Ooh, let's pull the tag off of the object. So we're gonna make this private, so we don't have to keep getting it. Private string tag. And then let's say tag equals object to pool dot tag. So now we have a reference to it. I'm gonna say serialized field just so we can see this in the inspector. Get rid of this duplicate. Remove component. Will it let me? I guess it'll let you. Oh, it's still private. So if I fire this guy up, see, now we've got tag bullet. And then when we get our instance, so we can't just use public static object pool instance. We need a list of pools, right? Oh, list object pool. So now we have one master list of pools. And let's see if instance contains. Let's do a find. Ooh, bonus. We're going to do a predicate. So a predicate is pretty much just a function that returns a set. If you write JavaScript, kind of similar to lambdas or Java lambdas. I know JavaScript uses promises like this, but we can say object, which is each object that we're going to get passed in is going to run through this list, and we can say if object dot object to pool, yeah, object to pool dot tag equals tag to return. Or should we say this? Let's do tag to return. We're going to find, or we should find whatever we're in the awake. All right, if if this is already in our object pool, then do we destroy it? Because we can have multiples. Yeah, let's just destroy it. We're going to blow it up, and we're going to warn the user. Only one only one pool of each tag allowed. Tag exists already. Sweet. So now we won't have duplicates, right? Why are you not? No. Oh. And then we're going to return. Oh, maybe it's not find. Find returns. Find actually returns something. Let's do contains. Right. We can put a predicate in contains. No. Convert all. No, that's not what we want. Exists. Exists. So exists will return a true or a false. So now we can say return true over all of our objects. But we have to iterate ourselves then. For each object pool in instance. Right? I'm probably royally messing this up. So exists, put a predicate. Oh, does it want return? No. So if we do find it, return nothing. If we don't find it, this isn't the method we want. Yep, royally messing this up. If exists, yeah. Does it check each one? I'll go pass. All right, let's try the simple case. So this is going to iterate over all the objects. So then we can say bool tag this equals, right? And so if tag exists, now we do destroy. Actually, let's just destroy this, right? We just want to destroy the component and warn our user. Ooh, bad concatenation. This debug.log. Oh, capital L log. All right, so this object is going to wake up. It's going to find the tag of the object we're going to pool. We're going to find out, does this tag, is there an instance of a pool that already has this tag? So that's what this does. So it's a little weird because this exists will pass every single version or every single item in the instance into as ob. We're going to check the tag. If it's the same, yes, return true. If they all return false, it returns false. If it does exist, we're going to destroy this and then just in case return, because destroy happens at the end of the frame, I guess, right? Now we need, so this instance, we're going to create some pooled objects, right? And add them to the pool. Neat. All right, so now we have this pool is in the list of instances. So now we need to make this static. So we can call it from anywhere. And we say, I want an object with this tag from the pool. So we're going to need to recheck, because this is in a static context, we're going to need to check if our list is in here. So we're actually going to duplicate, again, repeating myself. Say if it exists, because this get pooled object exists in a static context, we can call it from anywhere. If no instance exists of any object or any pool, I believe you can still call this. We'll have to do some testing behind that. So if tag exists, so if it does exist, we're going to do something. And that something is all this. We're going to go in and find it. But first, we have to find the pooled object inside the list. So we say instance dot, we already know it's in there. Find, yeah. Because it's a list, we can't use an index, can we? No, because it's a member instance.find. And we're going to do another predicate list. So we're going to say object pool, pooled objects, or no, pool equals instance.find list if list.tag equals tag, the one we passed in. Are we having scoping problems here? Yeah, because there's a tag in the instance. We're going to say, change this to tag to find. So now we know it exists. We're going to find it in our list. So if whatever this list is, the tag is the tag to find, we're going to return it. Return list. And then if we don't find it, return null, or we return nothing. Bool, false. Oh, do we return the list or do we return true? Find, gives an object pool. I think we return true to tell the predicate that yes, this is it. And we return false to say no, this is not it. So now we can say pool.pooled objects and just kind of duplicate that guy down. instantiate it. We need to add a new one. Cool. So now, not all code pass return. Oh, so if the tag does exist, right? And if it doesn't, we return null. And we can actually get rid of this one because this will, if this goes in and it'll find it, it'll iterate over the list. If it can't find one and it can't expand, it's just going to fall out the bottom of this. So no. So now we should be okay. All right. I am going to, what should our second, let's make another bullet. Uh, let's shoot cubes. Yay, cubes. I'm going to tag this, add a new tag, cube bullet. Tag you with our cube bullet. We're going to make it fly. Let's make our cubes slow. Why not? Box collider, you need a rigid body. Don't use gravity. Or do we want to use gravity? Gravity. Can't talk today. We need to fix our chute. Change this to QB bullet thing. Create a prefab. Boop. Get rid of our instance. Now in our game controller, we should be able to go into scripts, add another object pool, add our cube bullet, set it to not 3, the rest will do its thing. Now we need to fix our script. So now our instance no longer exists. Like this is an static method, no longer an instance. So we can say get pooled object, and we need to tell it which pooled object we want because it wants the tag. So let's say bullet tag, tag to shoot, right? Let's make that a member variable. Let's make it private. Tag to shoot. Let's do something fun. So if we're shooting, and we can shoot, let's say if get key down, what do we want to do? Key code dot A. Perfect. Nailed it. Then tag to shoot equals, what do we name it? Create an enumerator for this. QB bullet. Named it cube bullet. Cube, and spelling and capitalization is important. It's cube bullet. If we're not holding down A, this is probably the worst way to do this, but that's okay. Tag to shoot equals just regular bullet. So now, if we're holding down A, it will go out and find a cube bullet to shoot, and then shoot the cube bullet. If we're not holding A, it'll find a regular bullet and go find a regular bullet for us to shoot. All right, play. So if I just click, oh, object reference not set to an, we didn't set those guys up. Oh, we never set up our instance of our lists. So if instance equals null, instance equals new list of object pools. So now the first object pool that gets instantiated or wakes up will come in here. It'll say, hey, there's no instance, create a list. The second one that comes in will say, oh, there's already an instance. That's great. I'm going to skip over and do my thing. Shoot a bullet? No, we're not shooting a bullet. But you can see we've got 3 cube bullet thingies and 3 regular bullets. Because in our controller, we have 3 in each. You can see all the references there. So let's see where we went wrong. Come in. This is great. It's already doing its thing. Pooled object, new list. Awesome. I think this is okay. I think it might be somewhere in our shoot. No. Because this shouldn't have changed because we only messed with the object pool. I have a feeling this guy might be null, which means our object pool is going to be coming back null. So let's debug this guy. Debug log trying to shoot what do we call it? Tag to shoot? Tag to find. Trying to shoot tag to find. But I'm going to say tag exists. I'll just give us true or false, 1 or 0, what have you. Trying to shoot bullet, but false. You can see these are popping up. If I hold down A, am I holding down A? No. Still trying to shoot bullet. But this should be coming back true. Because we only have one instance. Did we not add, we did not add our current pool to the list. So we have the instance, we have a list of lists, so we have to add our pooled objects to the instance list. Instance dot add pooled objects. So now the instance has our pooled object, right? Oh, this. Because we instantiated this one, right? There's our bullets. We're not getting cubes, but we're getting bullets. So we're getting closer. And it keeps doing bullets. I don't know why it doesn't say key bullet. If input.get key down, key code A, that should be okay. Tag to shoot, right? We fire a bullet. Hmm. So tag to shoot should be okay. Let's do this. Log shooting tag to shoot. So that should flip. So shooting bullet, if I hold down A, that's not doing it. Why is my input manager not working? Input, get key down. Oh, it's only true on the first frame. If we want to check subsequent frames, we need get key. So if we happen to click the mouse and press the A key at the same time, then we get a cube bullet. But now it's any frame. There we go. There goes our cubes. Bullets and cubes. I'm going to jack up count to pool to 20. And I am going to slow down the player shooting to like 4 per second. There we go. Shoot regular bullets. And then if I hold down A, there goes our cubes. And they're super slow. I can shoot 20 of them. Neat. Speed these guys up. Make them 2. And let's make them kinematic so they don't hit each other. Bullet. A cube. Cube, cube, cube. Awesome. So we've got 2 objects with 2 different size pools coexisting. Let's make it so we can make more. Cube can expand. Now we can make all the cubes we want. Excellent. So I think we're good. Thank you guys for watching and following along. Feel free to message me on Twitter at CodeMonkey0 if you guys have questions. I'm going to be trying to do this every week, whether that's on Tuesday or not. I will make plenty of posts whether or not that's going to happen, but I'm going to stick for Tuesday for now. Thanks for watching.